All right, so this is an algebra of functions kind of problem. I'm given a function f of x and a function of g of x, and I'm given 6 different manipulations to do with these functions. And then I'm supposed to find the domain of the result of these 6 different manipulations. Well, I remember to find my domains of my resulting functions, it's good to know the domains of my original functions. And so g of x, well, that's just a polynomial, right? X to the 1 plus a constant or minus a constant. That's a polynomial, and polynomials, the domain of a polynomial is always negative infinity to infinity. So the domain of my g of x is negative infinity to infinity because it's a polynomial. My f of x, it's not a polynomial, so I got to think a little bit more about that. And the 2 ways that I have to exclude things from my domain would be an even radical or an even fractional denominator of a negative number. It's like square root of a negative, 4th root of a negative, 10th root of a negative, that kind of thing. Or division by 0. There's no radicals, there's no fractional exponents in this one, so division by 0 will have to be what we look at. And the only way to have a division by 0 here would be if x equals 0. And so the domain of f of x is just going to be x not equal to 0, or more fancily written in interval notation, my domain will be negative infinity up to 0, not including 0, up to infinity. And so that's a union between negative infinity and 0 to infinity, not including 0. Okay, well, let's do my f plus g of x. Well, f plus g of x, I kind of don't like this notation for people that are learning algebra. It's an elegant notation for people that are, publishing and using this math. But for learning algebra, I think it gets a little confusing. This f plus g of x, I like the translation a little bit more. That's f of x plus g of x. And to me, that helps us realize that, well, wait, it's just whatever function I have for f of x added to whatever function I have for g of x. And so that's going to be the same thing as 1 over x plus x minus 3. Okay. And I know that unless I've got division, the division in there changes things a little bit. All of these algebra function problems are just going to be the intersection of the 2 domains, right? The intersection of f of x's domain with g of x's domain. And so what I'll do is I'll say that this is negative infinity up to 0, union with 0 up to infinity. And so it's that or that intersected with negative infinity to infinity. And if I look at the intersection between those 2, well, I'm really just kind of anding 2 different intervals together, and one interval is all numbers. Well, it's really just going to be the more restrictive of the 2 intervals, because anything that gets excluded from this one will automatically have to be excluded from all real numbers. And so in this case, all I'm really going to get back out here is my negative infinity to 0 union with 0 to infinity, excluding my 0. And so that's going to be literally the domain of all of these calculations, except for, well, it actually isn't going to be it'll be the domain of all of those. Okay, so that's my f plus g, and that's the domain of my f plus g. And you can also see this just by looking at the result here. The only way that I have to exclude from that is there's no radicals in that, would be a divide by 0. The only chance of divide by 0 would be 1 over x. Well, the only x value in 1 over x that leads me to 1 over 0 is x equals 0, and that's the value that I have to exclude here. Okay, let's do the same thing with f minus g. F minus g of x would be the same thing as f of x minus g of x would be the same thing as 1 over x minus x plus 3, x minus 3. Just trying to do a little work ahead and messing myself up in the process. All right, well, that's going to be, I'm going to distribute that negative through, and so I'll have 1 over x minus x plus 3 And again, I already said I know the domain is this negative infinity to 0, 0 on to infinity. And I can get it either from knowing that it's the intersection of my f of x and my g of x's domains, or I can look at that and determine what my domain of that function should be. Okay, then I'm asked to multiply f times g and then f times f. And so f times g of x would be the same thing as f of x times g of x. And so I'll have 1 over x for my f of x times x minus 3. And so that'll be x minus 3 divided by x. And it will have the same domain as the first two. Now, this one was a little bit different because it's f times f of x. And so it'll be f of x times f of x, which will be 1 over x times 1 over x. And so it'll literally be 1 over x squared. And I can look at this and I can come up with that it has the same domain here, right? Because the only thing that we're really worried about is divide by 0 problems. Or I could look at it's the intersection of f of x's domain and itself. Either way, it comes out to that value, right? Because this is f of x's domain. F of x's domain intersected with itself is just itself, because it's saying something's overlap with itself. And so we just get the original domain of f of x back out. Okay, I've kind of been rushing through these first ones because it's these last ones where the domain calculation, oops, wrong color to choose. It's these last one where the domain calculations are a little bit different. I've got f of x divided by g of x and then g of x divided by f of x. And the reason they're a little bit different is because now I have to think about what are the values of g of x in the first one and what are the values of f of x in the second one, because I can't let them equal 0 respectively. Okay, so if I got f over g of x, so I have my, oops, go back to green, f over g of x, that's the same thing as saying f of x divided by g of x, which is the same thing as saying 1 over x divided by x minus 3. Well, I can simplify that complex fraction a little bit, or I can turn this divide, because it's the same thing as saying 1 over x divided by x minus 3. I can turn that into multiplication by looking at the reciprocal of the x minus 3 and then turn that divide into multiplication. So what I have really is 1 over x times x minus 3. Now, I know that it still has this domain, but then we also have to check and make sure that g of x, because g of x is in the denominator, we also have to make sure that g of x does not equal 0. And so I would take that x minus 3, so for my f over g, I would take x minus 3, set it equal to 0, and solve. So I'm going to add 3 to both sides and say x cannot equal 3. And so for my domain, it'll be negative infinity up to 0, not including 0, union with 0, up to 3, not including 3, union with 3, on to infinity for the domain of that. And it makes a lot of sense, because if I put 0 in here, principle of zero product says that is 0 for the denominator, and I can't have a 0 for my denominator. So I must exclude 0 from the domain, which is exactly what that does. Same thing, if I put a 3 in there, I get a 0 for my denominator, so I must exclude 3 from my domain. That's what that does. So I feel pretty good about that answer. Now, if we take a look at g divided by f of x, we'll get something kind of eerily similar, but with a different domain here, right? So if I do that, that's going to be g of x over f of x. And my g of x over f of x, what's that going to do? That's going to be, in this case, x minus 3 divided by 1 over x. Well, that divided by could be multiplied by the reciprocal of the 1 over x. And so what we're really going to get is x times x minus 3. And then the domain is going to be the domain of the f function overlapped with the g function, which is this. And then it's going to be that, and also have to check to see if f of x equals 0. But if I look at my f of x equals 1 over x. So I need to check, f of x equals 0. But f of x equals 1 over x. Well, 1 over x, because it's got a 1 in the numerator there, can never equal 0. The way we can see that is if we set this equal to 0 and try to solve for x, we'd multiply both sides by x, and we'd get 1 equals 0, which is a contradiction, so no solution. And so there is no x value that will turn that into a 0. But I could also go back to my rough definition of what is a fraction, and my numerator tells me how many pieces I have. The denominator tells me what size are those pieces. And I don't care how small you make that piece, I still have one piece left. So I can never have 0 pieces. And so f of x can never be 0. And so that means that my original domain, which is just the overlap of those, which gives me that, is my domain of this function. And so my domain of this function is negative infinity to 0, union with 0 on to infinity. I hope that helps out as far as an example of some algebra of functions and determining the intersection and union operations so that we can calculate the domains of these algebra of function results.